Hi everyone. So let's now solve more PYQs related to sliding window protocol and go back protocol and selective repeat protocol, right? Okay. So some of those PYQs are really tricky, but we will solve all of them, right? Let's solve this PYQ. Let's see that what they're saying. So this PYQ has been asked in GATE 2009, and let's just understand this particular question and let's just see what they're saying. Frames of 1000 bits are sent over 10 to power 6 bits per second. Duplex link. Duplex link means full duplex. It means what? That whenever you are transmitting the data, at the same time on the same link, the other direction is also available. And tell me, isn't it the case always? See, whatever we have seen, isn't it always the case that we have been on the full duplex link, which means whenever we are sending the data and we are receiving the ACK in between, whenever it is traveling back in between, aren't we sending many other frames? Tell me. Yes, right? So I mean, even if they do not specify whether it is duplex link or not, it doesn't matter, right? Even if they do not specify. So anyway, I hope you understood. So that's fine. I mean, even if they do not specify. So suppose that bandwidth, okay, is given to be us as 10 to the power 6 bits per second. Then what does this mean? Does this mean should I be just, have I ever done this half of the bandwidth in one direction, half of the bandwidth in another direction? Have I ever done something like this? No, right? So don't get confused with this duplex link. Some of the students are getting confused that, okay, duplex link means it is full duplex. That's why bandwidth should be half in one direction or not. No, that's not the case. Even whatever question we have solved till now, it was the full duplex link only, right? And bandwidth, you don't need to half or don't need to double or something. So what does this mean? 10 to the power 6 bits per second in one direction at the same time with the same bandwidth, which means 10 to the power 6 bits per second is in another direction, right? So both the direction are having 10 to the power 6 bits per second at the same time. Okay. Is this okay to everyone? See, that's what we have been doing till now also. It is just that explicitly they are saying it is a duplex link. It doesn't make any difference to our calculation or to our answer. Okay. Anyway, let's just continue further. Okay. So they are saying the propagation time is given to us is 25 milliseconds. Frames are to be transmitted into this link to maximally pack them in transit. Okay. Within the link. This is interesting. So let's just see that what it means. So they are saying that this is not might not be related to any particular protocol, which means may not be stop and wait, may not be go back, and may not be selective repeat. I mean, since they have not specified any specific protocol, let's not even assume any specific protocol, right? So what they're saying, what is the minimum number of bits required to represent a sequence number distinctly? Okay. So first we need to understand that how many packets we are sending, right? How many packets we are sending, and based on that we will see. So we are saying that here frames are to be transmitted into the link, maximally pack them in the transit. So what does this mean? See, let's just understand this question first, and then we will be solving, right? Okay. Just a second, let me make some space so that I can explain. So they are saying that whenever, let's suppose this is some link. Okay, this is some link. And whenever you want to send from A to B, they are saying you want to send in such a way that frames are to be transmitted on the links to be maximally packed in the transit. And further, they have specified this. Okay, so what does this maximally pack mean? They are saying that what is the minimum number of sequence bit will be minimum number required to represent the sequence number distinctly. Assume that no time gap between the packets of the transmission of two frames. So what does this mean? It means whenever you are sending one frame, then after how long you are sending the next frame? After 5 minutes, after 0 minute, after 1 minute, after 2 minutes. So what does this mean? After how long you are sending? Immediately. Yes, immediately. There is no time gap, right? There is no time gap between the two frames. Whenever you are sending one frame, immediately back to back you are sending the next frame. Okay, I mean, we have seen these kind of things also. I mean, in go back end or in sliding window, or I mean the selective repeat also, we do the same thing, right? We immediately send it. Or do we wait? No, right? We immediately send it. So that's what they're also saying, that we are immediately sending it. Okay, so frames are to be transmitted on the link to maximally pack them in the transit. Okay, so which means you want to immediately send it. Now suppose you are immediately sending, Okay, you transmit one frame, and then this, okay, sorry, this reaches here, this last bit reaches here, and then there will be ACK. So in between this time, this total time is called RTT, right? This total time is called RTT. So in between, can you tell me that can you send more frames? Yes, we can definitely send more frames. So what they're saying, that you are sending back to back, you are sending many packets back to back, but how many you are sending? Such that link is maximally pack. Okay, frames are to be transmitted onto this link to maximally pack them in the transit, which means you are sending back to back such that if you're sending back to back, then ultimately it should be maximally pack. Okay, if you want to send in such a way that it is maximally pack, which means back to back you want to send, then how many packets you can send? See, whenever you are saying that, okay, this particular bit, okay, I mean, you can take any bit. Let's suppose that this is our ultimate goal, in the sense that we want to send back to back, right? And such that this is maximally packed. Okay, so let's just see that how many packets we need to send to have the maximally pack. Tell me a general question, that if I give you in TT time, how many packets you can transmit in TT time? One packet, right? In 5 TT time, 5 packets. Similarly, in 10 TT time, you can transmit 10 packets, right? Okay. Now, suppose there is one bit, okay, some bit is traveling from here to here. In that much time, how many packets you can transmit? How much time it will take from here to here? It will take TP time. In TP time, how many you can transmit? In TP time, you can transmit TP by TT, or you can say A packets you can transmit, isn't it? So you can say that you have TP time. In this TP time, you can maximum you can transmit A packets, right? In this TP time. Is this okay to everyone? Maximum you can transmit A packets. Now, if I in fact transmit A packets, then after TP time, how it will look? Which means that at t equal to 0, if my link is looking like this, okay, if my link is looking like this, where there is no packet on this link, then can I not say that at t equal to TP, which means if I send back to back, then whatever bit I'm sending, okay, whatever bit I started sending here, that particular bit, this is the first bit of the first packet or whatever, right? This is the first bit of the first packet. This will reach at the end after TP time. Can you tell me where it is? This is here. Is this okay to everyone? This is the first bit of the first packet that will reach to the end, the first bit of the first packet. Is this the last bit of the first packet? No, this is the first bit of the first packet which will reach here. So this is first bit of first packet. This is, I just started transmitting the first packet, which means first bit of first packet. So which means if I'm sending back to back, then this is the packet, this is the last bit, this is last bit of the first packet, this is the first bit of the first packet. Okay, I hope you understood the difference here, last bit and first bit. Okay, if I'm sending back to back, then can you tell me how many packets I will be having here on the link now at t equal to TP? How many packets I will be having here? A, right? A is the number of packets, okay, on the link. Which means if you really want to maximally pack, then you need to, if you want to full this link, okay, if you want to full this link, okay, with the maximally pack, then you need to send A packets, right, such that there is no time gap and that can be sent back to back. So you want to send A packets here, which means it is given that propagation delay is 25, and the transmission delay, if you check, it is in the bits, length is in the bits, this is also in the bits. It will be length upon bandwidth. That will in the seconds. But if you want, you can convert that to milliseconds, which means you need to multiply by 10 to the power 3. So can you tell me the transmission delay here? 1 millisecond, right? 1 millisecond is the transmission delay. So it is given to us that transmission delay is 1 millisecond. The propagation delay is given to us 25 milliseconds. So in this propagation delay, in this particular time, how many packets you can send? In this particular time, you can send 25 packets, right? Isn't it? If you can transmit 1 packet in 1 millisecond, then 25 packets in 25 milliseconds, right? So now let's just read this question. So what they're saying that this is some information, length and bandwidth is given. The propagation time is given. Frames are to be transmitted onto the link such that it is maximally packed in the transmit within the link. Okay. Now, what is the minimum number of bits that is required to represent the sequence number directly, distinctly? So basically, you want to have maximally packed link. Okay. Now there are multiple options in the sense that you can keep on having the maximally packed link, which means that, so what do I mean? See, is this okay to everyone, by the way, that at t equal to tp, it will look like this? Okay. Is this okay? If at t equal to 0, if this is this, then at t equal to tp, that will be there. Okay. Now you tell me that how it will look like at some other time, maybe t equal to tp plus 1 or something like that. Okay. I mean, at t equal to 25, it is looking like this. Now, let's suppose there is some other time. How it will look like? So you will say that at t equal to tp plus 1, where 1 is the transmission time, right? I mean, just after some time, basically t equal to tp plus 1, you can have plus 0.5 or anything. Okay. I mean, I'm just saying plus 1. Okay. It need not to be the transmission time also. Don't worry about it. So it will be something like this. I mean, there will be some gap here and the packets will be moving further, right? Is this okay to everyone? Is this okay to everyone? There will be some gap here. Let me know. Now, do you really need to have this gap, or you can transmit? I mean, you can keep on transmitting, right? I mean, this need not to be any gap. You can keep on transmitting. Okay. So you can keep on transmitting. Let's suppose you have some packet to transmit. You can keep on transmitting that also. So there need not to be some gap. You can keep on transmitting, right? After t equal to tp plus 10 also, the link could be full. See, if you have enough packets, is there anyone who can stop you to have this link not full? Anyone? There is no protocol, there is nothing, absolutely no one who can stop you to stop send. Okay. If you have enough packets, you keep on sending. No one is stopping you. Okay. No one is stopping you to have this link full always. That's not the point, but okay, they're asking that even if you want to have, okay, let's suppose कि ऐसा होता है ना कि let's suppose life में एक dream है यार, एक बार तो मुझे maximally pack देखना है, just one time I want to see this maximally pack. तो कितने minimum packets होने चाहिए कि एक बार तो देख सकें? See, बार देख सकें तो फिर तो बहुत सारे packets होने से good, right? I mean, if you want to keep on seeing this maximally pack, you have as many packets as you want. I mean, nobody is stopping you, right? So what I'm trying to say here is that if your dream is just to see just once कि यार जिंदगी में एक बार मुझे maximally pack देखना है, so how many packets minimum you will be needing here? 25 packets, right? If you just want to see at once that okay, this I want to see in my life, I just want to see at once, at least I want to see this maximally pack, then I need 25 packets. If I have 24 packets, then I want to be able to see maximally pack. If I have 50 packets, then yeah, I will be keep on seeing maximally pack for some time, right? For maybe 50 or I mean like for some time, maybe 25 milliseconds or something, right? I will keep on seeing maximally pack. If I have 100 packets, then maybe for longer duration I will be keep on seeing maximally pack. If I have 500 packets, maybe for too much duration I will be keep on seeing maximally pack. But if I have at least 25 packets, then at least once I will be seeing maximally pack, right? Okay, so I hope you understood this. Now let's just see this question once again. Okay, let's just read out this question. What they're saying: okay, what is the minimum number of packets you will be needing for the maximally pack, just to see that you can send maximally pack? So minimum you need 25 packets, right? Minimum you need 25 packets. So that's why how much number of bits you require? Okay. So the number of bits that is required for 25 packets. So I think 2 power 5, I mean 32, right? 25 packets if you want to send, then if you're using go backend, right? I mean, I'm just taking the minimum both sides. So if you're taking go backend, then total number of available sequence number must be 26. Is this okay to everyone? See, if you are sending 25 packets, then what should be the available sequence numbers that you will be needing? At least you will be using go backend. Matlab receiver window side, at least there will be one, right? So you will be definitely needing one as receiver and 25 as your sender, right? 25 as the sender and one as receiver. Which means, see, what I'm trying to say, these 25 packets that you are sending here, that these many packets could be there in flight at once, right? I mean, they are on the link at once. Can you send more than 25 packets? Yeah, if you have more number of bits, you can definitely send more than 25. Nobody is stopping you. But 25 packets are there on the link on the flight at once. On the flight, you understand, right? On the flight means that you can send 25 packets. Can you send more than 25? Yes, you can definitely send more than 25. Okay, it's not an issue. So if you see this 25 or 26, you need at least 5 bits here, right? So I think D is the correct answer, right? Okay. See, bandwidth won't be half in full duplex or double in full duplex. I mean, we are always using full duplex. Every question was a full duplex only, right? So now since the propagation is okay, we can send 25 frames. If we want to send 25 frames, to be more precise, I think if we want to send 25 frames in the flight at once, then we need 26 available sequence numbers. Right. Anyway, the answer won't differ, but we need at least 26 available sequence numbers, which means we need at least 5 bits, right? Okay. So D is the correct answer here. As you can see, this question have been very popular. Okay, this question have been very popular on the GATEOverflow, which means this 115 upvotes means it is very popular. But have you understood this question? They're asking minimum. Okay, they're asking minimum number of packets you need to see that. Okay, what is the I mean, to see the maximally pack. Okay, they're asking minimum number of packets. Okay, minimum number of packets or minimum number of bits you require. Okay, let me know if there is an issue, right? Okay, so you need 5 bits. Now let's just see this question. This question is actually the continuation of the previous question only. This question is also from GATE 2009. This is question number 58, and that was question number 57, right? As usual, ISRO has copied this. I mean, ISRO ने ये GATE के PYQs copy करते रहते हैं. So this is question number 58. That was question number 57. All the data is same. Everything is same here. This is the next information that you have. This is question number 57. Okay. Just now we have solved this question. Suppose that sliding window protocol is used with the sender window size 2 power I. So what was the I that we have? I is the number of bits. I was 5. Remember? I was 5. Now they are saying that suppose that we are using the sliding window protocol. And now we, do you remember how many packets we were sending? I think we were sending 25 packets at once, right? Which means this was a window size we were using. Now they are saying that let's just use the window size, which is 2 power I, which is 32. Okay. They are saying that let's just use the window size of 32. Is this okay to everyone? Can you tell me, by the way, if TP is 25 milliseconds and TT is 1 millisecond, then what is RTT? Okay. Actually, the transmission time, if I also give you the transmission time of ACK is also 1 millisecond, then now you tell me the RTT. Okay. Now you tell me the RTT. If I also tell you the transmission time of ACK, okay. So now we will read out this question, but now the RTT, as you know, the transmission time of the frame plus 2 into TP and then this. So it will be 52, right? Okay. Every one of you have answered 52, and I hope that is fine to everyone. So let me know if there is any problem in understanding that why RTT is 52. So as I can see that every one of you have answered 52 correctly. So I'm assuming that you understood that why RTT is 52, right? Okay. So now let's just do one thing. If this is the RTT that we have here, then can you tell me that how many packets, if the transmission time is 1 millisecond, then how many packets you can transmit in this RTT? 52 packets second, right? 52 packets you can transmit, definitely not an issue. Okay. Anyway, but they are saying that I in the previous question was 5 and you are actually transmitting 2 power 5, which is 32 packets you are transmitting. Okay. So they are saying, suppose the sliding window protocol is used and the sender window size is 2 power I, which means 32 packet at once you are transmitting. Although you could have transmitted 52 packets, but that's fine. That's fine. Okay. If you see, if you transmit these 52 packets, okay, first of all, tell me, can you transmit these 52 packets? Yes, right? Okay. So you can definitely transmit these 52 packets, which means how many different sequence numbers you need? At least 52 for sender and one extra for the receiver. So 53 you will be needing. And based on that, you can again calculate the number of bits that we need, which is 6 bits, right? 6 bits. You can definitely calculate number of bits. So if someone asks you, I mean, this question, and okay, see, the question that I'm asking is a little different from what is given here. Maybe I'm asking you, let's not worry about this question for 1 minute. Okay. Let's not worry about this question. I'm asking you, suppose RTT is 52 millisecond. Then if I ask you, what is the minimum number of bits required to have 100% efficiency? It means what? 100% efficiency means what? You're completely utilizing this RTT, isn't it? Which means it means that we are sending 52 packets. Isn't it? Is this okay to everyone? We are sending 52 packets. If we are sending 52 packets, in that case, we need 53 different unique sequence numbers. It means we need 6 bits. Okay. That's what I meant to ask. Okay. Anyway, coming to this question, let's just see this question now. So what they're saying that this is RTT. You can send definitely 52 packets, but they're saying you are just sending 32 packets, not 52 packets. Okay. So where is this? Now, acknowledgements are always piggybacked. So this piggyback actually means that along with the data, okay, we will see in the TCP again, along with the data. Anyone who has covered TCP before from some other resource, do you know that with the data we also send the ACK? There's a sequence number and sequence number X and ACK number Y, something like that, right? So which means sequence number, which means data number, and ACK number, which means acknowledgement number. So basically, along with the data, we not only send the data, if the acknowledgement is piggyback, always piggyback means that along with the data, we also send the ACK. Okay. So which means we are not only sending the ACK, the receiver is not only sending the ACK, receiver is also sending the data. Okay. Or data size is assuming that the frame size is same, which is 100 bits. So what is the transmission time for the ACK itself? The same time as a data will take. So that's why I've taken the transmission time to be 1 millisecond, because the acknowledgement are always piggyback. Piggyback means that data and ACK both are in one packet only. Okay. Both are data and ACK. Okay. Okay. You try to solve this question and let me know what is the answer you are getting here. So what they're saying that after sending 2 power I frames, which means 32 frames you send, then how long you have to wait? That's what they are saying before transmitting of the next frame. So how long you have to wait? So what is the answer you are getting? Okay. C, right? Yeah. So this is a simple question only. They are saying that instead of 52 packets, which you can definitely send at maximum, you are sending 32 packets. So in that case, basically what will be happening, that RTT is 52 seconds, sorry, 52 milliseconds. It means that from the moment, okay, so sorry, so basically this is sender, this is receiver. From this to you till you get the first AC key, right? This total time is 52 milliseconds. There is a transmission delay for ACK, and then you will be getting your packet, your ACK basically. Okay, so this time is 52 milliseconds. You are sending how many packets? See, this total time is 52 milliseconds. Now, these are the 32 packets you are sending. So 32 packets you can send in how much time? In 32 milliseconds. So what is the remaining time from here to here? 20 milliseconds only. So 20 milliseconds you will be waiting, right? Okay, so this is easy question only. Answer is C. But you can see, even though it is easy question, still, I mean, there are 82 upboards here. There is 117 upboards here, right? Have you understood this question? Let me know. Okay. Okay. So now let's just solve the next question. Okay. If ACKs are not piggyback, I think this will be 19, right? Yeah, this will be 19. Yes. Because RTT will be one lesser. Yes, you are right in that case. Okay. By the way, you understood, everyone? You understood what does this piggyback ACK means? Piggyback means the data and ACK are in the same frame. Okay. Which means we are sending ACK along with the data. You will get to understand more in the TCP that how this piggyback works. Okay. TCP uses the piggybacking ACK. Let's just solve this question. So what they're saying, host A is sending data to host B in full duplex link. Again, even if they do not specify this is full duplex or not, don't we always have the full duplex in our sliding window protocols? Right? Then only we keep on sending, then only we are waiting. Like, I mean, one way we are sending, another way we are, acknowledgement is traveling, right? Okay. So they are saying A and B are using the sliding window protocol for flow control. The send and receive window sizes are 5 packets each. Okay. So they have given the sender window size as 5 packets, right? Sender window size is 5 packets. And the receiver window size also has 5 packets, right? So they are saying that sender window size is 5 packets, right? Sender window size is 5 packets, and the receiver window size is also the 5 packets. Data packets sent from A to B are 1000 bytes long. So they are saying that the length of the data packets is 1000 bytes. And the transmission time in such a packet. Okay, so transmission time is also given. Okay, bandwidth you can calculate if it is required, but yeah. Acknowledgement packets sent only from B2 are very small and require negligible transmission time. The propagation delay over the link is also given. So transmission delay and propagation delay is given 200 microseconds. What is the maximum achievable throughput in this communication? Okay, so in RTT, what is RTT here? TT plus 2TP, right? So it will be 450 RTT, right? 450 microseconds. So they're asking that in this RTT, we are sending 5 packets. So they're asking basically the throughput. So can you tell me the throughput? Do you remember how we calculate the throughput? In the RTT, which means in this 450 microseconds, we are sending 5 packets, right? So you can calculate the throughput, right? In the 450 microseconds, which means in 450 microseconds, we are sending 5 packets, which means we are sending 5 into 10 to the power 3 bytes, right? We are sending this much. Yeah. So in 1 second, yes, Siddharth, that is correct. So yeah, Siddharth is writing the the method, which is really nice method. I mean, this is one of the method to calculate the throughput. We have seen that using the efficiency also you can calculate, but yeah, this is also the good method, right? Okay. So in 1 microsecond, you can send 5 into 10 to the power 3 upon 450 bytes, right? But they're asking in 1 second. Even 1 microsecond we can send this, then into 10 to the power 6. This will in 1 second we can send this, right? These many bytes per second, right? This is the throughput. Okay, cool. So can you tell me what is the answer you're getting here? 10 to the power 6, actually, you don't need to take care of this 10 to the power 6. It is anyway separate. Okay, just do this calculation. This is 5,000 upon 450. Okay. So 5,000 upon 450. 11.11. Okay. So this number is coming out to be 11.11. Right? Into 10 to the power 6 bytes per second. I think B is the correct answer here. Right? So at GATEOverflow, there were multiple solutions which are given. This is the selected one. This is the best answer. And this was the, this was the second method. So let's just see that how they have solved. So if you see, like I have taken this also as a screenshot, RTT they have calculated, and then in this RTT they are sending this. So is this the same method we have been using? Is this the same method? Yes, right. In RTT, in like this is length upon just the time, right? So this is the same method that we are also using. Okay, and there is another method. You first find out the efficiency and then you use this formula. So which one is good? Which one is better method? What do you think? The first one, right? Still, this has been selected as best. Can you or this has been having the most upvotes? Can you guess the reason? Can you guess the reason why? Yeah, you first need to also calculate the bandwidth, right? I mean, too much calculation. I mean, bandwidth is also not given. Yeah. So the only reason that why people have upvoted this too much is because why? Is because of that they remember the formula only. They know this formula, okay, that efficiency. They blindly calculate the efficiency, they blindly calculate the bandwidth, and then they do this. And people are appreciating this method. Okay, people are appreciating. You see the number of votes. People are appreciating this method because that person is using the formula, and this person is just using the common sense. Okay, that okay, in this RTT, how much we need to send? This is just a common sense. I mean, we can obviously solve with both of the methods, right? But we will be solving with this method, right? So Shivam is saying that I also use the second method. So Shivam, why you are using this method? This is the okay. I'm calling this a second method. This is the first method. So which one you will prefer, by the way? The first method, right? Obviously, it is very straightforward. In RTT, how much you are sending? That's all. Right? Why you even need to calculate the bandwidth? Why you even need to calculate the efficiency, then multiply both? Right? You don't need to do that much, right? Okay. Okay. So now let's just move further. Let's solve this question. So what they're saying, consider the selective repeat sliding window protocol that uses a frame size of 1 KB to send data on 1.5 Mbps. By the way, like this particular method that we have used and that we have used to solve this method, if you obviously you must be recalling that this method we have used many times, right? We have used many times this method. Okay, many times we have used this method. I mean, we have solved the questions using this, both methods. Many questions we have solved using the both methods, and then I told you to prefer this method, right? Because this is direct. Okay, now you solve this question. Consider selective repeat sliding window protocol that uses a frame size of 1 KB to send 1.5 Mbps link. So here the bandwidth is given to you. It is 1.5 Mbps. Length is given to you 1 KB. Propagation delay, which means one-way latency, is given to you something like this. To achieve a link utilization of 60%, which means they are saying the efficiency is 60% here. The minimum number of bits required to represent the sequence number field. Okay, so they are saying that, okay, how many bits you will be needing. So what is the size of the window, first of all, that you will be needing here? Okay, so let's just see what is the size of the window. So do you remember the efficiency will be n upon 1 plus 2a, right? I mean, in normal circumstances. So this is the efficiency which is given to you as 60%. 60% means 60 upon 100, right? You just calculate this n. What is this n you are getting here? N will be the transmission time. It will be length bytes, right? This is in the bytes. So now completely in bits. 1.5. This is in the bits. Okay. Length upon bandwidth. This is in the seconds, but let's suppose you need everything in milliseconds. So 10 to the power 3 multiply. So this is 6 will cancel out. So 8 upon 1.5, right? .3, right? So it is coming out to be 5.33. Okay. So 5.33 millisecond. It is this. Now you multiply. I mean, you first calculate this A. TP was given to us as 50 milliseconds upon 5.33. Okay, this is 9.38. So 2 into A plus 1. So can you tell me 1 plus 2A is what? Okay, just let me know. Okay, so see here, this is 50 upon 5.33, right? 50 upon 5.33. It is 9.38 into 2 plus 1. It is coming out to be 19.76. Okay, 19.76. This is your 1 plus 2a. Now you need n. N will be 60 upon 100 into 19.76. Okay, let me directly have the answer. Yeah, it will be approximately 11.58. Okay, see here, 9.38 we are getting A. They're getting 9.155. Okay, they have taken kilo as 1024. Okay, not an issue. So, I mean, it should be, by the way, given. If it is not given, for the frame size, I mean, for the length, if they are saying frame size, then the size of the data, if they are talking about the size of the data, then we can keep it at 2 power 10 also. Okay, if they're talking about the size of the data. If they're talking about the channel things, which means the bandwidth, then this mega is not 2 power 20. This is always 10 to the power 6. Okay, this is always 10 to the power 6, but this kilo, if this is the size of the data, okay, this is not the data, this is the channel things, right? Channel things is always in 10 to the power, but I told you that computer store the data in 10 to the in 2 power. So it could be 2 power 10. You can take it 2 power 10 or 10 to the power 3. Actually, it won't matter for the answer. Okay, they should be given it. If they have not given it, then they will take it as a range. Okay, they are asking the minimum number of bits, so the answer won't matter. Anyway, so here the n is coming out to be, can you tell me what is the n here? .85, right? 11.85. Now, which means you need this much window, right? You need window of 11.85, which means that you need window size should be 12, right? Window size should be 12 if you want to achieve at least 60% efficiency, which means that if window size is 12, okay, so They are using selective repeat. If the sender window size is 12, then can you tell me what should be the receiver window size? It is also 12. Then which means available sequence number should be greater than or equal to 24. Right? Should be at least 24 sequence numbers you should be having, which means you should be having how many bits? At least 4 bits will enough? No, right? So you will be needing 5 bits. So that's why 5 is the answer here. Okay, understood. I mean, it is just a calculation, but I hope you understood. So you need, see, the efficiency is also dependent on, I mean, ultimately, see, efficiency is dependent on what? That how many packets you are sending. How many packets we are sending, right? Efficiency is dependent on how many packets you are sending. Now, interestingly, the number of packets you are sending is dependent on what? This is basically window size, right? Window size. Interestingly, dependent on sequence numbers, available sequence numbers also. Available sequence numbers. So which means if you are having lesser bits to represent sequence number, maybe you might not be achieving that good efficiency. Okay. Have you understood? Now let's just solve this question. So let's read this question probably, and then we will try to solve. So what they're saying, consider a network connecting two systems located 8,000 kilometers apart. The bandwidth of the network is given to us. The propagation speed is given to us. So they are saying the distance is 8,000 kilometers, right? Bandwidth is given, and the propagation speed, which means velocity, is also given 4 into 10 to the power 6. It is in meters per second, okay? And then length is given or not? Average packet size, length is also given to us, which is 10 to the power 7 bits. And bandwidth is given to us is 500 into 10 to the power 6 bits per second, right? Okay. Go back and sliding window. The network is used with this full capacity. Okay, which means you are sending back to back. So how many packets you can send at max and RTT? How many packets you can send? 1 plus 2a, right? 1 plus 2a. Okay. So the minimum size in the bits. So if you want to have this much as a window, okay, and they have not given, okay, they have given, this is go back end. So if this is the window size, then first of all, tell me what is the window size you are getting. Okay, maybe instead of doing the calculation, I can directly tell you the transmission time and I mean the propagation time and the transmission time, right? So like, I think this is also easy to calculate. The propagation speed will come out to be distance upon velocity. So this is 10 to the power 6. I think this is 2, right? 2 seconds. And the transmission time will come out to be length 10 to the power 7, and this is bandwidth. So 1 upon 50, I think, right? So 1 upon 50 seconds, which is 0.02. Right? Let me first check these calculations. These calculations are correct. So which means that you are having this A as A will be TP upon TT. So what does this say? TP upon TT. So 2 upon 0.02. Right? So this will be 100. Yeah. So this will be 100. So how many packets you can send at max? 201. 201 at max packets you can send. If this is the sender window size, then what is the receiver window size in go back again? Always 1, right? Always 1. Then you can add both of them, which means it will be 2, not 2. These many different sequence numbers you will be needing. So I think 2 power 7, 2 power 8 will work, right? So I think 8 bits will work. Okay. So how many minimum number of bits you require is 8. Okay. Easy question only, but yeah. Okay. Have you understood, or should I be explaining it again? See, this is 1 plus 2 is the maximum number of packets you can send, right? So if you can send these many packets, where do they have written? Okay. In RTD, okay, they have calculated it in RTD. They have, I mean, this is just 1 plus 2a basically. Okay. Anyway, we know the 1 plus 2a. So then plus 1, and then you can do this. Okay. Cool. Okay, now let's solve this question. So they are saying in this question that 20 kbps, which means bandwidth is given to you, is 20 kbps, right? Okay. Now, what else they are saying? They are saying that propagation delay, TP, is given to you is 400 milliseconds. The transmitter employees go back and IRQ scheme with n set to 10. Okay, window size is set to 10. Sender window size. Assuming that each frame is 100 byte long, okay, so length is also given to be 100 bytes. So can you tell me the transmission time? Length 100 bytes, which means into 8 upon 20 times power 3. This is also the bits. This is in the seconds, but you can convert that to milliseconds. Then it will be 40 milliseconds, right? 0, this. Yeah, 40 milliseconds. So you are getting 40 milliseconds as transmission time and 400 milliseconds as propagation delay. So what is the maximum data rate? Maximum data rate means throughput, basically they're asking. So what is the maximum throughput that you can get? What is the RTT here? RTT is basically, if you remember, let me just tell you. That we say, let's see, if you are sending some packets, then this is first packet, second packet, and okay, let me just have the first packet. Then this is the propagation delay and all. So some people calculate the RTT from here. I mean, we have calculated the RTT from here, and there are many standard textbook and many resources where they have calculated RTT from here, right? Okay. Anyway, let's just see this question. So what they're saying. So here we always calculate RTT from the first bit, basically, including the transmission delay. So some textbook I have shown you that they have not included the transmission delay, right? So here, what is the RTT? Is TT plus 2TP. It is coming out to be 40 plus 800, which is coming out to be 840 milliseconds. So now in 840 milliseconds, how many packets you are sending? 10 packets, right? In terms of byte, can you tell me? I think 1000 bytes, right? So in 840 milliseconds, you are sending 1000 bytes. Can you tell me in terms of bits, which is as good as 8000 bits? So in 1 second, okay, in 1 second, how much you are sending? Can you tell me? See, in 1 millisecond, you are sending how much? 8000 bits upon 840. This much in 1 millisecond. In 1 second, you will be sending, I mean, quite more than that, right? So what is the answer? Here, if you calculate, it is coming out to be 9.52 kbps. So which is the correct answer? So since none of the option is matching, so maybe let's just see if they have calculated, if they have treated this as RTT, right? Maybe they have treated this as RTT. Maybe they have not included this, right? Let's just check. So if you include just this, then you will say in 800 milliseconds, right? Instead of 840, you will be having 800 basically, right? In 800 milliseconds, 1000 bits, right? So basically you will be having 8000 divided by 800 into 10 to the power 3, right? This is bits per second. So in kbps, you can just ignore this 10 to the power 3. So it will be 10 kbps, right? So if RTT is taken to be taken from here, then the 10 kbps is the answer. So since there is a 10 kbps is an option and 9.52 is not an option, so I will be keeping 10 kbps. Now, if 9.52 is also in the option, then both are the correct answer. Okay, then in that case, both are the correct answer, but you choose 9.52. Okay, in exam, if you have to choose, you choose 9.52. Why? Because it looks more, I mean, it is basically more promising and it is actually more accurate. Although some authors have calculated RTT from here, but this is the question from GATE. And I think this is the very first question where we are seeing that RTT they have calculated from here. Do you remember I told you that we will be seeing the GATE questions also where RTT will be from here? Right? So this is the very first question I told you where the RTT they have calculated from here. Okay, which is fine. Don't worry, I will show you more questions. I will show you more questions where they have calculated RTT from here. Not just one or two, I will show you, I think maybe 2-3 questions more. I will show you where they have calculated RTT from here in GATE itself. See, let me just show you that if you remember the MIT and many other references, right? So I think that was here. In which lecture I have shown you the multiple definitions of RTT. Okay. Maybe. Okay, not here. Yeah. So you see here that I have shown you that MIT, okay, MIT reference. In this MIT reference, they are saying that you can the estimate above one omits the transmission time of the packet, which means that RTT is not including. They have given both as answer that if you do not include RTT in the transmission time in RTT, if you include transmission time in RTT, right? So this is the diagram that we have discussed, and the question was this. This was the question where the answer is this, and in this answer they have included transmission time in RTT. In this answer they have not included. Then I have shown you that okay, this is the screenshot from Frozen. They have not included, right? And then I've shown you a screenshot from Tenenbaum. They have included this +1. And then I show, if you remember, I shown you Washington University. They have included, and they have actually copied Cross, and Cross is including. So this transmission time is included in RTT or not included in RTT. It is actually sometimes author dependent. But in the GATE, we will always include it. If after including answer is not given, then we will see that, okay, let's just check if we do not include. Is this okay to everyone? So there are multiple standard resources itself. They included or they do not include. So this is the very first question in the GATE we are seeing that you have not included, right? So let's just see the answer that it is given. So they are saying that see, okay, they are including and they are also getting 9.52. Then they are saying which is close to option B. So, but in this question, is this answer a good answer? Is this a good answer? No, right? So can anyone improve this answer? Can anyone write a good answer? So to write a good answer, just do one thing. Just cite all the resources which I have given to you here. Just cite all the resources and tell, and including the cross, okay? Including the cross. Do you remember the cross I told you? Maybe let me just show you. See, this is from Washington University. Here, if you remember, they are calculated. They are not including this transmission time, right? So you cite all the resources which are including, which are at least known to us, which are including, which are not including the transmission time. You cite all the resources, and then after citing all the resources, you come to the conclusion that okay, sometimes they include, sometimes they do not include. Then you give okay. Then you also give that example of GATE PYQ where they have included. GATE PYQs, there were included transmission time in RTT. Okay, and then give GATE PYQ itself. I will show you in next couple of slides. Give GATE PYQ itself. They have not included. Then come to the conclusion that this is just one example of the PYQ. There they have not included. Okay, can anyone write this much long answer, citing all the resources? And then also tell that in this GATE PYQ they have included, or I will tell you that there are other GATE PYQs they have not included transmission time in RTT, and then come to the conclusion that in this question also they have not included. Okay, can anyone try to write? Okay, it will take 1 hour, not much. If you want, you just try to write. Okay, and this will be one of the most popular answer you might be having, because actually this is the confusion of many students. Okay, and that should like what is happening, what is RTT? Okay, this is not clear to many students. If anyone can write it very clearly, then it will be great. Okay, now let's just move to the next question. Cool. So this is the question that we have here. Now, by the way, you understood the last question, right? Let me know if there is any issue with the last question. You understood this, right? Okay. Now let's just see this question. What they're saying: consider 128 into 10 power 3 bits per second satellite communication link with one-way propagation delay of 150 milliseconds. Okay, so the propagation delay is given to you, which is 150 milliseconds. Now they are saying selective transmission, selective repeat protocol is used on the link to send, but the frame size, okay, frame size is given to you is 1k bytes, kilobytes. Neglect the transmission time of the acknowledgement, the minimum number of bits required for the sequence number field. So, okay, they want to have 100% utilization. Okay, to have 100% utilization, what should be the center window? 1 plus 2 into TP. It is 150 milliseconds. Can you tell me TT in milliseconds? Length upon bandwidth, right? So bandwidth is this. Okay. So generally, actually, this kilo we are taking 10 power 3, but here it seems that we can take 2 power 10, right? I mean, this is the length of the data. Data length we are free to take into 2 power also. Okay. So should I be taking 2 power? Because I think if I do length upon bandwidth is also given in. I mean, they have intentionally given, I think, it to be 128 so that I can cancel this out, right? Is this okay? I can take it 2 power. Are you understanding why I'm taking 2 power? See, if this is the length of the data, okay, if this is the length of the data, then I can take in 2 power also. Okay, if this is the length of, or if this is a bandwidth, let's suppose bandwidth is given to you is 1 kbps. Can I say it is 1 into 2 power 10 bytes per second? Is this okay? Bandwidth is given, then it is not okay. If the data length is given, then it is okay. I mean, they should give it, by the way. But if they are not giving, I mean, by this question, I think their intention is to say that, okay, if the for this data length you can take in 2 power. Okay, yeah. So this data length of the frame can be in 2 power, but the bandwidth or these kind of things which are related to channel, which are related to electronic media, this is in 10 power. Okay, okay. So this is K. So I can take in 2 power anyway. So let's just take it in 2 power so that I think it will get cancelled out little easily. So here I'm getting length as 1 into 2 power 10 bytes. And if it is bytes, I can convert that to again bits. This is bits, right? These many bits upon bandwidth is 2 power 7 into 10 power 3. This is bits per second. Okay. So ultimately this is in second. Then if you want in millisecond, just multiply with 10 power 3. So this will get cancelled out. This is 7. This will be 2 power 3. Then 6, which is 64 milliseconds. Right? Okay. So this is 64 milliseconds. I mean, if you want, you can, again, if you want, you can take it to 10 power 3. I don't have any problem. Maybe let me see what they have used. Oh, nice. They have also used in 2 power. Anyway, like this is the intention which is very much clear from this question maker. Okay, like I completely agree that they should give. Okay, they should definitely give. But if they're not given, then you can take anything. Okay, the answer won't be changing for sure. So let's just keep it 64. Now this is the efficiency that we got. Now what they're saying, a minimum number of bits required for the sequence number field. Okay, so the window size, if you want the 100% efficiency, then what is the window size you are getting? 1 plus 2a. N is coming out to be 5.68. So you need to send at least 5.68 packets, which means that you need to have how many bits? Okay, this is N, or so let me see. Yeah, 5.68. So basically, this is basically you can send 6 packets, right? You can send 6 packets. If you can send 6 packets, then if it is selective repeat, then if the window size is 6, okay, if the sender window size is 6, can you tell me what is the receiver window size? This is also 6, right? Since both are 6, then available sequence number must be at least 12. Okay, I mean, this is at least 12, it should be, right? And I hope now you understand very clearly that why this is the case, and you don't directly remember this formula. Have you understood very clearly from this last lecture that why this is the case? Understood, right? Okay. So this available sequence number must be at least it must be whatever you are giving to the sender window and what receiver might expect next. Okay, summation of this must at least be your available sequence number. We have very clearly proved it in the last lecture. Okay. Okay. Now let's just continue. So basically from here you can say that I need how many minimum bits? 4, right? 4 bits. Okay. This is from GATE 2016. So now you can see one thing, that to have the good efficiency, you need to have good window size, and to have good window size, you need to at least have the bits in the sequence number. Okay. So ultimately the efficiency is also related to the bits, how many bits you have for the sequence number, because that is related to the window size. So basically you can say that efficiency and number of bits required, number of bits in sequence number, these both are dependent. I mean, this window size is in between. Efficiency is dependent on window size is dependent on this, right? So indirectly you can say the efficiency is also dependent on number of bits in the sequence number. Anyway, but I hope you are able to solve the questions at least. Okay, now let's just solve this question. So what this question is saying, that station A uses 32 byte packet to transmit message to station B using a sliding window protocol. Okay, so length of the data is given to you is 32 bytes, right? The round trip delay between A and B is 80 milliseconds. Okay, round trip delay. RTT is directly given to you is 80 milliseconds. And the bottleneck bandwidth is given to you is 128 kilobits per second. Okay, so what is the optimal window size that A should be using? Okay, so A uses 32 bytes packet. Now, first tell me what is the transmission time. To calculate the transmission time, here it is interesting, length, right? Length is 32 bytes. Okay, so this will be 32 into 8 bits upon bandwidth. What is the bandwidth? Bandwidth is given to you is 2 power 7 into, and this is kilo. Should I be taking in 10 is power, 2 power? 10 is power, right? This is bandwidth. So this should be 10 is power 3. So ultimately this is in the seconds. Now you can convert that to millisecond, right? Multiplying 10 is power 3. So ultimately it will be 2 power 5, 2 power 3, 2 power 8, right? So 2 milliseconds. It is 2 milliseconds. So the transmission time is calculated to be 2 milliseconds. Okay. Now, optimal window size is that you want to have the maximum efficiency. So how many packets that you can send? In the RTT, you can send 40 packets, right? You can send 40 packets. I mean, if this is 80 milliseconds, if this is 2 milliseconds, so in this time, we can send 40 milliseconds, 40 packets. Is this okay to everyone? If you can send 40 packets, then what should be the window size? 40 itself, right? Okay, so B is the answer. The RTT, so they're saying the RTT or the round trip time is the quoting from the Wikipedia. Yeah, do you remember from the Wikipedia also we have seen the definition of RTT? I mean, the very first definition we have seen from the Wikipedia itself, right? Anyone remember? There's a screenshot from the Wikipedia. Okay, so by the way, this answer, if I remember, is written by Arjun sir. So he's saying that this is now in many books, including the standard ones, they have used the RTT to mean just two-way propagation delay by considering the signal packet of the smallest quantity, so that the transmission time is negligible. The question is following the first definition from the Wikipedia. Anyway, I think we don't even need to debate here. I mean, this is good that he has written, but we don't require to debate this particular point here, right? I mean, we directly know that, okay, in RTT, how much you are sending. In RTT, we can send 40 packets. That's all, right? Okay, cool. Now, let's just solve this question. So what they're saying, station A needs to send a message containing 9 packets to station B. Okay, 9 packets. Okay, so which means I think window size is 9. Using a sliding window, window size is 3. Okay, the total 9 packets you need to send. Okay, window size 3. Go back in. All packets are ready and immediately available for the transmission. If every fifth packet that is sent is get lost in go back in, okay, no AC gets lost, then what is the number of packets you need to transmit? Total number of packets. I think you can do this, right? Let's start from sequence number from 1, doesn't matter. So this 5 will get lost, but if 5 is getting lost, then I think you need to send 5, 6, 7 again. Then 1, 2, 3, 4, 5. Then 7 will get lost. Then in that case, you need to send 7, 8, 9 again, right? Total 9 packets. Okay. So this 5 will get lost. Then 1, 2, 3, 4, 5. Then 7 will get lost. Then 1, 2, 3, 4, 5. Then 9 will get lost along with this 9. Okay, sorry. 9 is the total number of packet, right? So what is the total packets you need to send? 9 plus 6. Okay, sorry. 9 will get lost. If 9 is getting lost, then you need to again send 9. Yeah, you need to again send 9. So 9 plus 7, I think, right? I think 16. Yeah, 9 you again need to send. Okay. So 16 is the answer here, okay? Let's solve this question. This question has been asked in GATE 2007. So let's just see what they're saying. So there are 2 more questions only we need to solve, okay? Only 2 more questions. Let's just solve these questions. Do you want to try this question? Okay. So should I be just giving you, little bit, just telling you what they're asking? The distance between 2 stations, M and N, is L kilometer. So distance is given to you L kilometers. All bits, all frames are, length is also given to you is K bits long. The propagation delay per kilometer is T seconds. So the total propagation delay is given to you is L, right? Per kilometer is T seconds. So it is L seconds. Okay. Let R bits per second with a channel capacity, which means bandwidth is given to you, length is given to you, bandwidth is given to you is R bits per second. Assuming that propagation delay is processing delay is negligible, the minimum number of bits required for the sequence number field in the maximum utilization when the sliding window protocol is used. Okay. So if you're using the sliding window protocol, then what should be the window size? Window size should be 1 plus 2, right? Okay, this is T seconds. I thought this is 1 second. This is LT seconds. So what is the window size that sender will be using? 1 plus 2 into TP. TP is LT upon TT, transmission delay, which is length upon bandwidth, right? Okay. So what is the bandwidth that is given to us? R bits per second. What is the length? K bits. So length upon bandwidth. I think this will be K upon R, right? So this is the window size that you need. Okay. Now you let me know what is the answer you're getting. So they're asking number of bits. Okay. They're asking number of bits. So this is basically two LTR, right? 2 LTR upon K 1 plus. So what is the answer? So this is just a sender window. This is just a sender window, right? But you need at least one more. I mean, for the at least you will be using go back end, right? So plus 1 also, right? So here it will be 2 plus 2 LTR divided by K. Right? So this should be the available sequence number, should be this. This is just a center window. So available sequence number should be this. So that is why, what is the answer? I think you can take log of this. So A is the correct answer here, right? Okay, they have given C. Bits required. Here it is asked for general sequence. General sliding window protocol मतलब क्या? At least go back and तो use होगा ही ना? No, at least you will be using go back end, right? General sliding window means what? I mean, I don't think this line even making any sense. Okay, it is asked for general sliding window, not for go back end sliding. What it really actually mean? So you need the center window. Center window must be, center window should be this, right? Upon K. That I agree. Or maybe you can write like this: 1 plus 2L T R upon K. This is the center window only. Okay, this is the center window. If this is the center window, then at least for one receiver will be waiting, right? So the available sequence number must be +1. The only way it is answer C is that RTT is considering to be like this, right? If RTT is basically not including the transmission time, then yeah, then answer is C. But you should always include the transmission time. Let me just tell you should always include the transmission time until and unless this is given or there is only one option. Okay, if there are multiple options, then I think here the A should be the answer. Okay, maybe I can just check it once more, but as per me, A should be the answer. And in official gate, I don't know if we have the answer keys for gate 2007. It is too long back. Okay, I will check. I will check if we have the answer keys for this. But I strongly think that okay, A should be the answer. Okay. So let me just also look at this on the gate overflow. Let's just see what they are saying. So this question is on gate overflow also, right? Okay. So in the best answer, I mean best in the sense like their selected answer. So what they're saying that that we can send this much. This is the center window first of all, right? And what they're asking is that sequence number field in the frame for the max. So they are asking sequence number fields. So this is a center window and at least one receiver window will be there, whatever it is. I mean, whether it is your selective repeat or go back and at least one you will be needing for the receiver. So I strongly think that you should be adding one here and then this should not be the correct answer. Okay. And then I think answer should be A. So let's just see the other opinions here. I mean, whatever way you implement, there will be at least one size, right? So this person is saying when we are talking about sliding window protocol, we care about the sender's window. It is explicitly mentioned. If it is explicitly go back and also focus on the receiver's window. Sliding window is theoretical concept implemented using. Even it is theoretical concept. So theory to wrong nahi hogi na. Theory itself says that okay, at least one it should be there on the receiver. So even if it is theoretical concept, then it doesn't mean that you can ignore that, right? Okay, there is one other answer here. They are saying, yeah, see, that person is doing what? In go back end, this person is adding one. To the center window, it is adding one. right? So yeah, so this person is saying that C is the answer. In go back and if you're using go back and C is the answer, selected there will be different answer. But yeah, you should be adding one. So hence, I think the answer should be C. Oh, sorry, should be A only. I mean, this person is saying it doesn't mean that I mean that answer is A, but as per me, that as I can think that okay, this is the sender window, and you must be having at least one receiver window, right? Whatever you use, you must be having one receiver window. So as per me, A is the correct answer. I will check if there is anything I can find. Okay. So whatever is the official key, I can check. Okay, if that is available. Anyway, there are 1-2 questions that will be there. You can just ignore if there's any controversy. So by the way, nowadays they have the nowadays you can claim the question, right? So if in that case, I think you can definitely claim if they give you C as the answer. I don't think there is any strong supporting argument that can say that C is the answer. Okay. I can tell you many arguments that can say A is the answer, because at least one receiver window size will be there. Okay. So as per me, A is the answer. Okay. Now let's just see this question. This question has been asked in GATE 2006. Let's just see this. So what they're saying, suppose that it takes 1 unit of time to transmit a packet, which means transmission delay is given to you as 1 unit, right? Transmission delay is 1 unit. Okay. And then they are saying the link layer uses the window flow control protocol with window size of n packets, which means the window size of the sender is given to you is n packets. Each packet causes an ACK or n negative acknowledgement to be generated by receiver. So basically, they are saying that each packet uses the ACK or negative acknowledgement by the receiver. An ACK or NAK transmission time is negligible. Okay. Further, the round trip time on the link is given to you n units. So RTT is given to you is n units. And transmission time is 1 unit. Okay. So consider time I, which is greater than n, which means after RTT, they are considering some time. If only ACK has been received till this time, which means there is no NAK, then what is a Goodput? Goodput means throughput only. Okay. Evaluated the transmitter at the time I in packets per unit time. Okay. So what they're asking, it is actually one interesting question. They are saying that you are having some RTT. Okay. And RTT time is given to you is basically, is n units. Okay. So RTT time is given to you is n units. And transmission time is given to you is 1 unit, which means this is 1 unit. This is another 1 unit, another 1 unit, another 1 unit. So in n units, you how many you can transmit? In n units, how many you can transmit? You can transmit n packets, right? You can transmit n packets. Yes. So now here, this particular packet will go, and let's suppose, okay. So let's suppose that RTT is this, right? Which is n units. So these are how many packets in total from here to here? If this RTT is given to you as n units, then how many packets are there from here to here that you can transmit on the link? N packets, right? So these are the n packets that you can have. Now they are saying that you consider some time I, which is greater than RTT. Maybe I consider this time. Okay. By this time, see, you are getting 1 ACK. Now you are getting 1 ACK where? The moment you finish this RTT, the moment you finish this transmission of the last packet, at the same moment you will be getting 1 ACK. The first ACK you got here. Now, the moment you will be finishing, okay, you will be sliding your window and you will be transmitting 1 more packet. The moment you finish one more packet transmission, at that time you will be getting the next ACK. This is the next ACK you will be getting, because that at that time only, because see, this ACK and the next ACK is basically having the difference of just 1 transmission time, right? I mean, after 1 transmission time only, this ACK will be started and will be reached. So basically all ACKs are having just 1 transmission delay. Okay. So what I'm saying here is that that this is the first ACK you got where at the end of RTT. At the end of RTT, you got your first ACK, and then you will be getting the next ACK by the next transmission. You will be getting next ACK by the next transmission. So if this total time is I, okay, so what is this time after RTT? If this total time is I, then what is this time? This is I minus n. So in I minus n, how many more, in this particular time, how many ACKs you will be getting? Just see here that this is the first ACK that you have got by the end of this RTT. Now, even before this I minus n even start, okay, here you got two ACKs. If you just ignore this ACK, so you can say that, okay, in this 1 unit of time, 1 ACK, second unit of time, second ACK. So how many unit of time is there? I minus n unit of time is there. So I minus n ACKs you will be getting plus 1. Are you getting my point? See, by the end of this I minus time, you will be getting I minus n plus 1 packet, plus 1 ACKs. Why? See, just try to understand. This is the I minus n time, right? After this RTT, how much time is there? I minus n. In each one millisecond, how much ACK you are getting? You are getting 1 ACK, right? You are getting 1 ACK here. In next one, you are getting another one. So basically, in this I minus n time, you will be getting I minus n ACKs, and 1 ACK you have got even before starting I minus n. So total ACKs that you have got till now by the end of this ith time, total ACKs that you have got is I minus n plus 1, right? So see, just see here. Suppose this RTT is 10 milliseconds. Okay. Let's suppose I'm talking about I is maybe at 13 milliseconds. What is happening? Let's just check. See. Okay. So see here. I just want to check. At 13 milliseconds, what is happening, right? So this is one packet you are sending. This is another packet. So from here, you will be getting this first ACK here. This time is RTT. The moment you get your first ACK, this time is RTT. This time is 10 milliseconds. Is this okay to everyone? How many packets you have sent till now on the link? How many packets are on the link? 10, right? 10 packets on the link. So basically 10 packets are on the link. That is fine. Okay. Now they are talking about 3 more seconds. So this is 10 milliseconds have been passed away. 1 more millisecond have been passed away, 11, 12, and 13. So by the 13th millisecond, okay, by the end of this I, you will be transmitting 13 packets. That is fine. So basically this is total I time, or maybe you can say the remaining is I minus n time, which is 3 milliseconds, right? Okay. You will be getting 1 ACK here, another one here, another one here, another one here. How many ACKs you have got by the end of I? 4 ACKs, right? By the end of I, you will be getting basically not just 3, you will be getting 3 plus 1, which means I minus n plus 1 ACKs you must be getting. Have you understood? See, even before starting this 3 millisecond, you have got 1 ACK, right? That is why I'm adding plus 1. And in each 1 millisecond, you will be getting 1 more ACK, 1 more ACK, 1 more ACKs. So total ACKs you have got till this point is this much. So which means at the end of this I time, okay, you can say, can you not surely say that you have successfully sent these many packets because you have got these many ACKs only? So can you not say that, okay, successfully we have sent I minus n plus 1 packets, isn't it? Can you say, see, you have got 4 ACKs. Can you say total how many packets you have sent till now? Total how many packets you have sent till now? 13 packets you have sent till now. Out of 13 packets, how many ACKs you have got? 4 ACKs you have got, right? So you can say that 4 packets successfully you have sent, right? Successfully you have sent. Yeah, Akash is saying true. So Akash is saying, if we set I equal to n, then which means that we say that, okay, by the end of RTT, how many ACKs you have got? This will get cancelled out 1 ACK, right? Which is actually true, that by the end of RTT, you get 1 ACK, right? That's how the RTT is defined, right? By the moment you get your first ACK, this is the RTT, right? The total time. I mean, I agree that some people measure the total time from here to they say that this is RTT, and some people say this is RTT, right? Anyway, that is fine. So you must have sent 4 packets. So what is the throughput here? 4 packets you have sent in how much time? I packet. So 4 upon I. I mean, I minus n plus 1 upon I, right? And this is the throughput. These many packets you have acknowledged, which means these many packets you have sent in how much time? This is the number of packets per unit of time. They are asking per unit of time. Time is I only. So I minus n plus 1 upon I. I minus n plus 1 upon I. This is your answer, right? Let's just see. So which one is matching? Upon I. 1 minus n upon I plus 1 upon I is not there, right? Seems like if you do not have this plus 1, then I think this A is matching, right? I think this A is matching if you do not have plus 1, right? So maybe they have considered RTT as something else. So let's just see if you consider RTT from here. Okay. So let's just solve the same question, but let's just see if you consider RTT from here. Okay. If this is your RTT, which means if you say this is n, so if this is your RTT, then by the end of RTT, I mean, basically, you can say, actually it will be plus 1 minus 1 will get cancelled out, I think. Then you can say, let me just try to see if I can explain this a little more nicely. I mean, you can say that, okay, this time basically will be not I minus n. Actually, it will be I minus n plus 1, right? It will be the time. So in this time, you will be getting actually plus, this is the time I minus n minus 1. This is the time which is remaining. And in this time, you will be getting one more ACK, right? One more ACK, right? One more ACK. So it is I minus n. I minus n total ACKs that you have got in I time. So that's how you are getting your throughput. So basically, they must be considering this RTT from here. Yeah, this is really bad. I mean, they should at least mention. So this is, in this question, they have not mentioned, and the RTT they have taken from here, right? So let me just explain this once more, that how we are getting that as an answer. Yeah, let me just explain this. See what they're saying. Let's suppose, okay, let's suppose you have, you are sending how many packets on RTT? You are sending n packets. I mean, if RTT is given to you, it's n, which means, let's suppose you are measuring RTT from here. Okay. So this time is given to you as n. This time is given to you as n, right? Is this okay to everyone? That what they have given, at least this is okay. Let's assume that this time is given to you as n. Okay. I'm not including this much time. Now, after I time, where are you? So if this is I, now can you tell me, I time obviously from the starting, right? I time cannot be from this. So from this, if this is the I time, okay, if this time is I, can you tell me what is this time, the remaining time? In the remaining time, you will be transmitting one packet. So how many more packets you can transmit? I think this remaining time will be, if this total time is I, then I minus n plus 1, isn't it plus 1? This is one millisecond or 1 unit of time is transmission delay. So I minus n plus 1 means, if you just remove this bracket, I minus n minus 1, right? This is the time which is from here to here. Let me know if this is fine to everyone. ये समझ में आया? This is very easy, right? I hope you understood. So now in this time, by the end of this time, how many acknowledgement you will be getting? Even before starting this time, this is 1 ACK. In every 1 unit of this time, you are getting one, right? You are getting 1 ACK. So in this much time, you will be getting 1 ACK, which means in I minus n minus 1 time, these many ACKs you will be getting. But even before starting this time, 1 more ACK. So total ACK by the end of this time will be this much, which is I minus n ACKs. right? I minus n total ACKs you will be getting by the end of I time. Because in I minus n minus 1, you will be getting I minus n minus 1 ACKs. And even before starting this time, you already got one ACK, right? So I minus n ACKs you will be getting. So because of I minus n ACKs, you can say that successful transmissions was till this point. See, till this ith time, the successful transmission till this ith time is how much? It's I minus n, right? Which means the throughput will be, what is the throughput? Throughput is number of packets you are sending, okay, upon and how much time? Ith time. So packets per unit of time. So it is I minus n upon I. So which means I minus n upon I is the answer in the packets per unit of time, which means 1 minus n upon I. Okay, so A is the correct answer. Let's just see their explanation. Okay, so the I would have been I minus n can be then. Since the RTT is n, which is equal to window size, there is no waiting time. Okay, again, is this a good answer? See, I don't think it is a good answer. Goodput is just throughput. Okay, it is just throughput. Goodput is application level throughput. It is just one other name. You can consider it as one other name. So it is not a good answer. Why? First of all, they have not specified that what is RTT. They have taken they just like plus minus 1 का तो देखा ही नहीं. Answer लिखने से मतलब है. I mean, what I mean to say, कि somehow if I'm matching with the A, then based on that, what my answer is matching, based on that, I can write the explanation. It's like that, right? So we should not be doing this. So they are saying, let's just read out this answer. So they are saying, so successful delivery of the packet can be ensured if ACK has been received. That's good. So till time I, we would have transmitted I packets, but only I minus n can be acknowledged as the minimum time for the packet acknowledges n. So see, they have not clearly defined that, okay, they have taken RTT from where, right? Since the RTT is n, which is equal to its window size, no waiting time. So they are saying that that I minus n packets. So again, the RTT, they have not very clearly defined that, okay, RTT they have taken in this question is actually from here. Because if we are taking from very beginning, then we are getting something else as an answer. Okay. Okay. So Sangeet is asking, sir, earlier we would not be calculating throughput by how many packets we have sent or transmitted in RTT in first method. Or if I'm wrong, then we were considering also which packet got acknowledged. We are calculating by considering the packet acknowledged, not transmitted only. Yeah, earlier we are saying that we are sending the packet. It means that it will automatically got acknowledged. I mean, in those questions, we are assuming that it is acknowledged only. I mean, there was no loss or something. Okay. So efficiency or throughput that we have calculated till this point was not having any loss or something. If there was a loss or something, then the basically I can say then there will be the probabilistic analysis and the question will be very much complex. Okay. Here also they are saying that till this I time there is no loss. Okay, if they say, let's suppose till this I time there is some loss of with p probability or something, it will be too much complicated. So whatever question, yeah, I agree with you. So whatever question we have done till now, we were thinking or we were assuming that there is no loss of the packet. Okay, that's why we are saying maximum throughput. Maximum means that what is the best. Okay, which means that there is no loss of the packet and there is no other problem, right? In that case, maximum throughput we can achieve, maximum efficiency that we can achieve. Okay, if there is a loss of the packet, then obviously it will be lesser, right? Okay. Okay, so Divyanshi is saying that, sir, if one question, because we took n from the we took n from the beginning in the first one and received different answer from the options, and then we took from the second different. Does that mean that the both cases are not same? I mean, if we are getting different answer, how can be this same theoretically? No, this is same only. It is just a notation. Okay, it is just a notation whether you are using RTT from here or you are measuring RTT from here. It is just a notation. Okay, in this question it seems like they're measuring from here. That's why they have given those as options, right? Okay. Okay. So Sangeet is asking, should we think about the transmitted or acknowledgement in case of throughput? We should see if there's a loss. See, there is no question in the gate and nowhere else as per the gate level that we are having the loss and then we are calculating the throughput or something, right? So just based on the transmission, we are calculating the throughput till now, right? If they give you that, okay, there could be the loss or something, then the throughput you need to consider obviously loss, right? And you need to check whether the packet has been acknowledged or not, right? But in all the questions that we have done, we are assuming there is no loss. So whatever we are sending is actually eventually it will get acknowledged. So that's why we are saying maximum throughput. Maximum means in best to best cases, there is no loss of the data, there is no loss of the ACK. Otherwise, obviously, the throughput will be less, right? Or the efficiency will be less. Okay. So there is no question till now we have done where we were having the loss of the data or loss of the ACK, and then we are calculating the throughput, right? Because it is not required for the gate level. Okay, if that is there, then there will be some simple calculation, not the very probabilistic calculation. They will say that, okay, one packet will be lost, then you just consider out of 10. Let's suppose they will say that, okay, out of 10 one packet will be lost, then you can say that, okay, no problem, that if I'm transmitting 10, then I will just consider that, okay, instead of 10 I'm transmitting 9 only, right? So 9, let's suppose they say, if I just ask you this question, okay, that transmission time is, let's suppose, 2 milliseconds, okay, and I'm transmitting, okay, transmitting 10 packets, and out of that one will be lost, right? Tell me throughput by the end of you can say end of something like that, timeout of lost packet assuming so here they are saying that you are having the transmission time or something. So they are saying that you are sending 10 packets, and then out of 10 one will be lost, right? So by the end of timeout, how much what is the throughput? So basically you are spending 20 milliseconds to transmit, right? And then after the 20 milliseconds, maybe let's suppose they say that after the 20 milliseconds that the last packet is getting lost, let's suppose, and the timeout is also given to you, right? Timeout is also given to you. Then you can say that, okay, you can say that you are sending how many packets? You are sending 9 packets, right? 9 packets in how much time? You are sending 20 milliseconds, and let's suppose after this 20 millisecond timeout starts, then in this timeout, right? So this is your throughput. You're just sending 9 packet, right? I mean, you're not sending more than 9 packets. I mean, depending on the values, you can definitely able to approach that question also. I mean, they have not asked till now, but you should be definitely able to approach depending on the values, whatever they give you, right? Okay. By this understanding is enough. Okay. So by the way, now we have completed all the sliding window protocol questions. As far as I know, all the questions with the theory with very good, as far as I can I can think of that with a very good explanation of every topic. So now this topic, including the sliding window, including the stop and wait, and go back and select and repeat, is completed. So from the next lecture, we will be starting a different topic, which is media access control. Okay. There are protocols like we will see those protocols, media access control protocols. Okay. Yeah. Thank you, Dibyanshu. So Akash is saying ki in this previous question, we are having this much. I mean, I can just write it, not here. Basically, let me write it. Yeah, here. Okay. So in this question, he has also written out that at what time we are getting the ACKs. Okay. So here at I equal to n plus 1, I mean at time of n plus 1, maybe at this time, we have got 1 ACK. Okay, n plus 1 is this time. Yeah, n plus 1 is this time. So here we have already got 1 ACK, then 2 ACK, then 3 ACK like this. Yes, that is correct. Okay. This is n plus 1 time. Okay. Cool. So thank you, everyone. Take care. Bye bye.